Good morning, everybody. First of all, my name is Ricardo Borges dos Santos. I am a researcher in the field of computer science from São Paulo, Brazil. I am associated with the Universidade Federal do ABC, and I have been researching digital harvest certification. And this is a very interesting theme I'm going to talk about with you. I will share my screen. And I'd like to give you an overview of what we're talking about. We are talking about a novel method for agro product certification, the IGR token. It uses smart contracts and blockchain technology to assure third-party certification of the products that reach consumers. One of the motivations for this is the fact that we have chocolate today as one of the biggest sources for enslaving children. Children work in a slave-similar situation in Ivory Coast, in Burkina Faso, in Ghana, and this is a huge number of kids. We're talking about 2 million children that are working on less than $1 a day on a slave-like condition due to the fact that the big producers of chocolate, Hershey, Mars, Nestle, and all the others, cannot guarantee that any of their chocolate was produced without child labor. That's a very tough statement. It means that we are contributing to children being slaves of these conditions. This has been the subject of a documentary, 2017, The Dark Side of Chocolate. Another issue which is also involved in certification of harvests is deforestation. We have deforestation actually being produced in many countries, but the most famous may be the Amazon, Brazil's Mato Grosso, for example. We can see here that a large amount of land, which was previously a forest with a huge biodiversity, has been changed into monoculture crops, possibly soya beans. The same applies, for example, for this Peruvian Amazon area, where the Mennonite colonies are destroying the forest to produce some monocultural crop. The term greenwashing may not be known to everybody, but basically greenwashing means you advertise more than you do for the environment. So one of the best definitions that I know is communication that misleads people into overly positive beliefs about a company's environmental practices and products. That is, you try to show what you're not actually doing. This is an example here of what is very probably greenwashing. We have this wrapper. This is a label on eggs. There's a dozen of eggs. Actually, it's only 10 eggs, and they charge more than the price for a dozen, where they have all types of claims. All these ABCDs here are claims, basically organic claim, no antibiotic claim, homeopathic medication claim, no cages claim, certified organic, certified humane Brazil, but no single evidence. There's nothing here that will evidence what they're saying. So are these greenwashed eggs? Even for premium products like this chocolate sold in Europe, you cannot totally ignore the fact that this may be greenwashing. I'm not saying it's greenwashing, but it's no evidence of the claims. They claim it's 100% certified sustainable sources, and it's from Ghana, but there's no evidence on that. With the certification of harvest, this would be possible, as I will show you soon. What is our problem? The research gap that we have been investigating is industrial food products, especially those which are mixed, we call them commingled or processed commingled, have claims on labels that consumers may or may not believe. The fact that we have a marketing activity in between a branding activity, and these people have a lot of money, They have a lot of resources and they have a lot of expertise to convince that they are the source of truth. If they write something on a label, the consumer should, without much discussion, believe in that. And this is not really true. So we have a clash here. We have a clash of the user consumer requirement, evidence of the claim, versus the industry right to protect the intellectual property. Note, both of these rights and requirements are legal. I mean, it is perfectly normal and legal for the consumer to require more information, whereas it's also perfectly legal for the processor and commingler to protect its intellectual IP, intellectual property, which is basically the sensitive data, the suppliers, the recipe, and all the related information to that. So this is a conflict of legitimate interests. The responsible, sustainable farming practice is directly influenced by consumer choice, but it has to be informed. So it's a consumer choice on the supermarket, but he has the need and the right to have the full information and evidence. And how can that move forward? They are willing to pay more for this informed choice, and this additional payment should incentivize all the stakeholders along the chain, especially those farmers that have had more diligence and have used sustainable and socially accepted farming. There is one important fact here. If you have first and third party certification, you should always go for the third party certification. I'll explain that. The first party certification is basically the producer claiming what he does. Second party would be the consumer going to the farm and checking that, which is virtually impossible. But the third party certification involves a third party called authority. They have one single interest: to maintain their reputation. They live off their reputation. So the certification process has no interest in the transaction itself, and the third party is free to decide what he will write in the certificate. So the third party certification can be applied and is one of the best methods of creating alternative practices for social and environmental friendly properties. One very important initiative was the Organic Food Production Act, which has had a lot of important influence on this and has been, let's say, overused, and also has some very difficult challenges. The main challenge being that the certification is done on the farm level and not on the harvest level. So the farm will have exactly 1 or 2 years to continue working as they wish. Until the next certification, they have to show some certain characteristics on how they produce their food. That's not good enough. We need better control methodologies. So the certification of a type or a farm, or a certification of each instance or a harvest, is very important, because each harvest brings different climatic conditions, different seeds, different chemicals. So they are totally different harvests and totally different fruit and crop. This is also reflected when you have a good harvest. Usually there is a typical fraud that will have more final products at the retail end than the quantity of product produced in during the production phase in the farm. So this happens to fine food in general and wine. So you see more bottles of the vintage so-and-so, if the vintage is good, being sold than actually produced. It is a fraud. It is sometimes called mass balance fraud, sometimes known as double spending fraud. And this also happens to protect the designation of origin, where people actually use allegations which cannot be proven except if you use some type of certification. So the main objective of this study was to establish a method for third-party certification of ingredients for foods that can easily and very readily available to anyone with a mobile device. So if you have a mobile device and you're at the supermarket, you should be able to see from the product what the main ingredients were coming from and if they were certified by any third-party authority. But this cannot harm the industry's intellectual property or any business sensitive data. So this is a balance, a clash between two important legitimate requirements. So what we want is basically to have this picture from consumer all the way to the farm without any interruptions here. We will use, we have used proven concepts such as those from IFT, Institute of Food Technologists, and we are going out for the most difficult parts of the supply chain, which are the commingled parts. Bakery is a typical commingled supply chain family, and also dairy products. These other families are not as difficult in this sense. So different traceability actors, different food families. We are also using from IFT the notion of CTE, critical tracking event, which is basically when should we collect data. And this is, in a summary, when you have the food ingredient being transacted, changing custody. If I hand over sacks of wheat, this is a change of custody. What should I collect is also one of the findings from IFT, which we will follow. So which are the items that we need to track? How do we identify product lots? We use the barcode plus the lot date. So the latest date on the lot, which is usually printed on the label. How do we make this data available? Well, for someone to be in a supermarket with a cell phone, this is pretty much universal read access. So we have to be able to read it from our cell phone. It has to be reliable. We cannot allow it to be tampered. And it has to be also bribery resistant. That means nobody within the system can change that data. To get to this type of non-functional requirements, we have to think of recent developments. The most important one was Bitcoin. Bitcoin was the first successful scarce digital object. So we have the possibility now to have digital objects which cannot be copied. Previously, anything in the digital world was typically copied. You could have more processing power, you could have more memory, you could have several instances of the same program running, you could have several email accounts. But as of Bitcoin, with the protocol behind it, which is called blockchain, also known as Nakamoto protocol, we can maintain the consistency of a database, and everybody will agree on a single block of a chain of blocks. So basically, the transactions can be ordered, and all of this data will be replicated in several distributed databases, but it's going to be consistent within a certain amount of time, typically 10 or 20 or 30 minutes, according to your level of assurance. It is auditable, so you can actually check what happens all along the chain. It is censorship and bribery resistance. It means if somebody is not happy with the content and wants to take down all of the computers, he can turn off the whole countries. Let's say we turn off all the power from the US. Even then, all the data is going to be available. In it prevents double spending. That's the most important, one of the most important characteristics, and not prone to bribery. Of course, there is the big question on scalability and energy requirement. We are all aware of that, but we also have seen a lot of progress in here. Right now, Bitcoin is still consuming almost as much power as the whole country of Venezuela and more than Austria. But this is has a very good initiatives which are reducing that and speeding up the transactions. how can we make the processing of this data reliable? And we can keep reliable, trustworthy data, but there are elements called smart contracts, which can do automatic behaviors connected to this data. So we have certain transactions which are coupled with conditions, and if these conditions are met, they will start doing certain steps of a programmable smart contract. They are open source, they are self-executable, that is, they will change the digital assets which they may be required to change if the conditions are met. They are unavoidable, you cannot switch it off, and they are bribery resistant. You cannot pay anybody to do something different to what the open source contract is actually stating. This is basically the concept. This cloud here denotes a digital world. Inside this digital world, we have real value, we have tokens which hold value, and we also have addresses which are internal addresses which are coupled to behaviors, smart contracts. In addition to that, you have external addresses who will trigger transactions, simple transactions, or even trigger internal addresses. So the EVM is the Ethereum virtual machine, which leads to the universal computer. So it runs all over the globe, the same code, the same output. Anyone can use and anyone can program, but also it's unavoidable. So it will happen whether one person wants it or not, depending on the conditions which are clearly written in the code. So it's unavoidable. So what is our development? We used both of these important properties of the blockchain to develop the IGR token smart contract suite. What does that mean? It means that we have a set of smart contracts who write data and collect data and modify data on the blockchain. This is here the virtual world, the blockchain world, in this case Ethereum, and this is here the real world where the products actually flow. So you have a farmer that will actually ask for a certification authority, any authority. This can be Greenpeace, this can be the University of Bahia or whatever, to visit its farm and check for a certain property. For example, if he sees any type of chemicals which are not allowed, or if he sees any type of devastation of the Atlantic forest, or any type of labor inconsistencies. This certification authority has full power to deny or not this type of allegation, and they will publish the certification in their URL. This is all described in this this paper, which was published a couple of years ago. So basically, this is the same scheme. So persistence layer, where you keep the data. This is the actors in the real world. All the inputs and processing that goes with it, all the wallets, everything that's necessary for a farmer to certify, and the link, which is the URL to that certificate, is passed on by the tokens as these physical goods are flowing and are being sold. So basically, you can sell your corn plus your certificates, or just the corn. If you sell only the corn with no certificate, it's a commodity. If you sell the corns plus certificate, it's a specialized certified product which is differentiated and will reach higher prices. So this will go from farmer to mill to whoever is processing along the way, and until it reaches the commingler. In this case, he will add here the labeling information, which will allow then this same data to be pulled off the blockchain, where the reseller, supermarket, or the end consumer may have access without any cost, without any difficulties to the certification. For that purpose, we developed the front end. It's an Android app, and you can download it from the Google App Store, install it in your Android, and you can read the barcode plus date, and then you'll get as a result the blockchain link, which you can then check on your browser. The results obtained so far were that the proof of concept was developed, deployed optimized, documented, tested on the testnet and on the livenet. So it is available. Today, the situation is such that the tokens will flow alongside, synchronized to the product, allowing for the client to check any type of claims directly from the certification authority's website. This link to the certificate will be pushed along the chain with the sell end of the tokens. So we have a synchronization between product and information. This looks like this. If you look at the blockchain, this is a blockchain scanner. You will see that there is a lot of steps along the way. From a certification authority issues certificates, sells ingredients without depletion, sells intermediate goods with depletion, commingles sells product SKUs with the product ingredients, commingles and so on. All these are the smart contracts that are used for different situations. But this will allow, if you go into the detail of one of those transactions, to see here basically the Greenpeace org certificates, Brazil peanuts, no jungle devastation, and so on. So this will have all the details such that you can go to the website and use that link to get all the details. You'll see here the barcode. You'll see also the dates. So it's totally easy to find. This proof of concept allows us to summarize the main findings after POC testing. Consumer functional requirements were achieved. That is, the link obtained through cell phones is available. Non-functional requirements, no double spending, usability, interoperability. So this is also achieved. We have a framework which is usable without any changes to the current productive processes. So this is very easy to deploy. And most important, all chain participants are motivated. They are basically incentivized to synchronize the information along the chain of custody. That's also very important because that makes it very usable. This is the matrix that I was asked to fill. So I understand that mobile technologies, as one of the pillars here, is directly related to all of these goals, these sustainability goals here. They will relate directly to mobile, to blockchain, Internet of Things, and cloud computing. There is no direct relation to big data, nor there is any direct relation to the AI, virtual augmented reality, or adaptive manufacturing. This is my point of view. I'll be happy to discuss this further in the workshop later on. So basically, I'm available for any questions. Our main goal here was to use universal information to avoid greenwashing. I hope you have any questions and comments. These are my contacts. Thank you very much.